Human brain. Human brain is a soft, whitish, large-sized and slightly flattened structure present inside cranial cavity of cranium of the skull. It is the central information processing organ of the body and acts as the command and control system. The weight of the human brain is about 3 pounds. The cerebrum is formed of a pair of large-sized lobes, called cerebral hemispheres. Each cerebral hemisphere is divided into 4 lobes: anterior frontal lobe, middle parietal lobe, posterior occipital lobe, and lateral temporal lobe. Cerebral hemisphere controls all the voluntary activities of the body. It is the seat of memory, will, intelligence, reasoning, and learning.
These are the cerebral hemispheres. They may look similar, but our hemispheres differ in size, shape, and function. Thus, even though the cerebrum is divided into 2 equal hemispheres, we now know that the left hemisphere processes information in a focused and analytical manner, and the right hemisphere integrates information in a more broad manner. We see that insights and solutions to ideas are more likely to occur in the right hemisphere. However, the hemispheres do not operate independently. Let's look inside so I can show you why this is. Here we have the corpus callosum. This is a thick band of fibers that connects the 2 hemispheres, and this band allows for extensive communication between the 2 hemispheres. This is really important for things such as logical thinking, even creativity. From research, we know that the biggest functional difference between the 2 cerebral hemispheres is language. Both speech and language abilities involve the left hemisphere. However, they involve different parts. The first neuroscientist to discover this was a man named Paul Broca. He found that a man who had a stroke could understand language, but could not speak grammatically correct sentences. This man had what we call aphasia, which is a deficit in the ability to speak or comprehend language. Due to his research, the part of the brain that's responsible for our ability to actually produce speech is named the Broca's area. The part of the brain that's responsible for the ability to speak in meaningful sentences and to comprehend the meaning of speech is named the Wernicke's area. It was discovered by Carl Wernicke. If there's damage to this area, the type of aphasia that results from this is fluent grammatical streams of speech. However, they have no meaning. So they're grammatically correct, they just don't have any meaning to them.
David Marsh, a specialized planner at Jyväskylä University, says that their research on multilingualism has shown that it puts people at an advantage when processing complex thoughts, which includes higher thinking and creativity, mental flexibility, interpersonal and communication skills, and may even delay age-related mental illnesses in the future. The most highlighted point in their research report is multilingualism's effect on memory function. An enhanced memory can have a huge impact on cognitive function, which is why multilingual individuals display superior performance in handling and solving complex problems. You might assume that the improved brain functions arise after individuals have gained command of multiple new languages. However, research states that changes in the brain's electrical activity may start as soon as you begin learning your second language. It is commonly believed that children are better able at learning a second language compared to adults. This might not necessarily be the case, because children and adults learn new languages in very different ways. By understanding, analyzing, and applying the knowledge through different learning processes, everyone, regardless of their age, is able to acquire a second language. For younger children, learning a new language comes as second nature. It is more intuitive and does not require a lot of conscious effort. Adult brains, on the other hand, process language in a more active way, which means that they are fully conscious about their learning process. Adults also have a much larger vocabulary, and they think and communicate in much more advanced ways than children, thus making it more difficult to progress quickly, and thus they should also be taught in different ways.
Words are just an outward expression of emotions and thoughts. They don't really mean anything on their own unless we assign them meaning. Design student Pei Ying Lin created this infographic of untranslatable emotions. My favorite shortcoming in the English language is that chasm that exists between liking someone and loving someone. You might really like them or whatever, you might adore them, but that's a little trite. The infographic shows that Italian and Korean have a word for love that's specifically for friends, family, inanimate objects, and pets. We have to use the same word to express romantic love to our wife or our husband as we would express to our mom or our dog or a really nice painting. That is insane.
Scientists have found there are differences. Bilingual brains activate in different ways depending on the language they're speaking, and also demonstrate incredible cognitive flexibility, switching back and forth between languages in a phenomenon known as code switching. And a new study has found an interesting link between language and time. The language you think in can impact the way you perceive time. Every language has its specific vocabulary for organizing the world around us, but when it comes to time, there are two general categories in which this is done. Distance, as in crossing an area, and volume, as in a space being filled. Swedish and English both use physical distances to express a measure of time. In English, we'd say a short break or a long wedding. We use these descriptive terms as though the passage of time is a measurable distance. In Greek and Spanish, on the other hand, time is marked with terms that refer to volume. In Spanish, you'd say a small break or a big wedding. So the question the researchers had was whether people who think about time with distance or volume measurements have a better sense of how much time has passed. To measure this, they had Swedish-Spanish bilinguals watch a line grow across a screen or watch a container being filled, the first a measure of time as distance and the second a measure of time as volume, and in each instance the subject was given a prompt in one of the two languages, duración in Spanish or tid in Swedish. The results show that subjects perceive time as it's measured in the language of their prompt. When given the Spanish prompt, participants estimated the time based on volume, in this case how full the containers were. When they were given the Swedish prompt, they could better estimate time as distance, using the line's travel as a marker. So this might not matter to any of us on a day-to-day basis, but it's interesting to have some scientific evidence pointing to how much language impacts the way we perceive something universal, the passage of time.